I return to talk about anodic oxidation because the previous videos have raised some questions that I would like to delve into, especially regarding the type of materials used in heat exchangers for applications in anodic oxidation. As I was previously mentioning, anodizing plants generally make use of highly corrosive fluids in their operations. Usually in anodic oxidation of aluminum sulfuric acid, 20% concentration, and temperatures of 20 to 25 degrees are used. This concentration type would enable the use of IAC 316 stainless steel from an isocorrosion diagram perspective, as it is highly suitable for this purpose. If not, that there is a risk in these systems that the temperatures are not always at 20 to 25 degrees, but can escape upwards, particularly when perhaps the system is stopped during the summer season. Upon examining the isocorrosion diagrams, it becomes evident that the corrosion of IC316 by this particular solution of water and sulfuric acid becomes a matter of great concern and raises significant worries. At this juncture, you must choose an alternative material. Typically, for plates, an alloy called Avesta, copyright 254 SMO, is utilized, which is a highly alloyed substance that exhibits exceptional resistance to chlorides, even in the presence of elevated concentrations of sulfuric acid, particularly at higher temperatures. If that's not enough, you can switch to titanium. Titanium is normally used with seawater, which has extremely high chloride concentrations, also with high temperatures, and it works very well for erotic oxidation. From a cost perspective, let's say that 316 2.54 SMO and titanium cost 100 and 200 respectively, depending on market fluctuations. For concentrations, instead of HCl, the situation becomes more complicated as titanium or Avesta are no longer sufficient, but hastelloy C276 is necessary, which is another alloy with high costs, relatively low availability on the market. But still, let's say it's a cold printable solution, so it works fine for plate heat exchangers. When we instead find ourselves with tubular heat exchangers, we can say that the choices are quite similar in the sense that tubes in 254 SMO can be found. Tubes in titanium are a bit harder to find, even the same goes for IC Stello. But let's say that other solutions also come into play, for which exchangers made with other types of materials can be used. I consider Incolloy and Monel. It is evident that we are beginning to transition towards extremely advanced materials that possess significant expenses, both in terms of raw materials and processing. When the corrosiveness of these substances is even higher, we definitely choose to use exchangers directly made of graphites for maximum efficiency. So they are exchangers built with mixtures of graphite, and clearly they are a bit special exchangers. They are no longer plate exchangers, tubular bundle. Yes, it is something that resembles it, but well, let's say that they are definitely very particular constructions. Next, we move on to the plastic heat exchangers. The well-known DuPont spaghetti are actually hair exchangers, which refer to a collection of plastic tubes that are submerged in the tank requiring temperature regulation. Other manufacturers produce them. Materials include polypropylene and PVC, depending on the application, workability, processing, and operating temperatures. It is important to note that when dealing with plastic, heating it can result in a strong odor. Therefore, caution must be exercised to avoid any unpleasant smells. In the pharmaceutical industry, and here I move from anodic oxidation, for example, when fluids are corrosive, glass exchangers and reactors are used. However, clearly we are discussing a distinct sector where the delicacy of the operations also differs. Let's imagine an anodic oxidation plant where metallic pieces are immersed in a tank, and these metallic pieces need to be anodically oxidized. In summary, it's very different from a pharmaceutical lab where I, as a pharmacist, measure components for a small reactor. Clearly, each and every application has its own specificity. I hope I have clarified some doubts. If not, please feel free to write to me. Greetings.